Okay, in equation solving, sometimes this situation pops up. This would be, for example, if we said pick a number, subtract 3 from it, and also add 1 to it. Take that first number, multiply it by 2, and take the second number, multiply it by 3, add it together, and you get 5. So this kind of situation is difficult to undo because you're using the AND operator. So I can't both undo two things at the same time. It is possible to work through this thing by using undoing, but it gets pretty messy. And I'll just show you what I did before. So I worked this out. I divided everything by 2. But you have to divide the whole side by 2 to follow this rule of the property of equality. So if I have one side is equal to another side, I can divide both sides by the same thing. So when I do that, it messes this up. It turns, so I have to divide both things by 2. So dividing this by 2 is good, it gets rid of that 2, but dividing this by 2, it turns that into a 3 halves, and that turns into a 5 halves. And then I subtract 3 from both sides, which is the same as 6 halves, and I get 11 halves. And then I want to get rid of this 3 halves, so I divide the whole thing by 3 halves on both sides, which is the same as multiplying by 2/3. And then I can combine these two like terms, these x's, right? This is 1x, which is the same as 3/3 x. Add them together, you get 5/3 x plus 1, and then I can subtract the 1 off from both sides, which is the same as 3/3. So that turns into 8/3, and we get rid of the 5/3 x and multiply both sides by 3/5, which I get 8/5. So it's a much more complicated process to try to do it by undoing. Now let's do the same problem, but let's do it by using what's called the distributive property. The distributive property, all it is multiplication over addition. If we have something multiplied by two things added together, it's equal to the multiplication of each part, a times b plus a times c. And you can see it, okay, here's a quick illustration of using the distributive property. This is 2 times 4, right? But instead of thinking of it as 2 times 4, let's think of it as 2 times 1 plus 3, right? That's the same thing as 4 is 1 plus 3. So if I had 2 times 1 is equal to 2. 2 times 3 is equal to 6. So if I add those together, 2 plus 6, I get 8, right? Well, I could have added them together first, right? I could have added them together first and got 1 plus 3 is 4. 4 times 2 is 8. So you see that this will always be the case, that the quantity of multiplying over addition will always be the same as the quantity of multiplying each individual part and then adding them together. Okay, so let's do that here. So we're going to have 2 times x minus, now I don't like subtraction, so I'm going to use the definition of subtraction to turn that into addition. So it's plus the opposite of 3, which is negative 3. So 2 times negative 3 plus 3 times x plus 3 times 1 equals 5. And then I'll just simplify these. Actually, let's just combine like terms. 2x plus 3x is 5x's. And then 2 times negative 3 is negative 6. Negative 6 plus 3 will be negative 3 equals 5. And then now I can do the rest by undoing like I am used to. So I add 3 to both sides, and I get 8 equals 5x. Divide both sides by 5, and I get x equals 8/5. The same answer that I got before, but I feel this was a lot simpler. Okay, let's check my answer. So 2 times 8/5 minus 3 plus 3 times x is 8/5 plus 1 does equal 5. Okay, so always check your answer. 8/5 minus 3, so 3 is the same as 15/5. And 1 is the same as 5/5. So we have 8 minus 15 would be negative 7/5 plus 3 times 8 plus 5 is 13 fifths. Okay, so 2 times negative 7 is negative 14 fifths, plus 3 times 13 is 39 fifths. And 39 minus 14 is 25. 25 fifths is 5, so that checks out. Alright, so that's using the distributive property and checking my answer. Let's talk about one more type. This is a very common mistake that people would make. So let's look at 2x plus 4 minus x minus 2 equals, I don't know, 7. Okay, so I could distribute this part. You guys are probably can probably do that on your own. So 2 times x plus 2 times 4, I'm just going to do that in my head, is 8. Now here, because this is minus, remember that subtraction is the same as adding the opposite. So if I add the opposite of x minus 2, what is the opposite of x minus 2? Well, it's negative x plus 2, right? So I would change signs on both of these inside here. Some people like to think of it as, it's like multiplying by a negative 1. You want to think about it that way, and then you distribute the negative 1. So 2 ways to think about it: negative 1 times x minus, so turn this into adding the opposite, plus a negative 2. So plus negative 1 times negative 2 equals 7. So 2x plus 8. Negative 1 times x is just minus x. Negative 1 times negative 2 is positive 2. And combine like terms, so I get x plus 10 equals 7. Subtract 10 from both sides and get x's negative 3. So yeah, you can think about when you have the minus right in front of the parentheses, that's the same as the opposite of whatever's inside here. So I could say plus negative x, it was minus, is x minus 2, so same as negative x plus 2. Okay, or you can think of it does the same thing, right? If I turn into negative 1 times x minus 2. So try to make sense out of that and see that it is the same thing if you say times negative 1, or if you just take the opposite of everything inside there. So negative 1 times x and negative 1 times negative 2 is positive 2. So you see that it's the same thing. So two different ways to do the same thing. And some people like to think of the negative 1 in front, some people like to just take the opposite of everything. Okay?